So in this lesson, we are going to automate what we have been doing in the previous lesson, the custom speech. Before we start, I would like to give you some introduction about it, because some of the things we are going to see, especially the code, the language, the tools we are going to use, are not very well discussed in this training. As a matter of fact, most of the things we are going to discuss in the CICD or MLOps can have its own training by itself. So it is not really Python. Mostly it is written in shell script, which is not by choice of mine because Microsoft sample is given like that. So I'm not going to make any drastic changes. I have done some fixes. A couple of my engineers worked and done some fixes on these samples. I'll be providing you the working sample. But if you're new to these things and if it is looking Greek and Latin to you, feel free to skip the whole thing, or you can simply enjoy the show rather than doing it. It's up to you. I'm going to leave it to you, but this is one of the topics we would like to discuss, but not a lot of background is given. So that is the disclaimer I want to give for next couple of lessons on the CICD. So due to the high complexity of this particular topic, or relatively high complexity of this particular topic, we have to subdivide this particular lesson into multiple different topics. So the first topic we are going to discuss is the review of what we have seen so far in terms of training, uploading the data, and reviewing the result. We'll do a quick summary of what we have done. Then we will look at the process of CI/CD in general, or automation of a build and a deployment. Building something and deploying something, or using or making it ready for usage. That's deployment is all about. We will see that. Then we will look at the code itself of the whole process, and then we will execute the code. So let's write the steps down. First, we are going to review. So review the whole process of training and deploying a model. Then CI/CD, the concept of CI/CD. Then we'll look at the code to automate pretty much the whole thing we discuss here. We'll learn some commands and GitHub actions and things like that. Then we will execute the whole thing and we'll see everything in action. So there are a lot of new things. As I said, this particular lesson is slightly above the level of this training, the whole training. There are a lot of concepts discussed and touched upon which are above the level of the training. So feel free to ask me any questions, and always, if you need some help with the code, feel free to reach out. So being said that, starting with the review of what we have seen. So we had a model, so the default baseline model we had, and that model used to give us some output by default. So what we were giving to the model in this case, we were giving speech. Speech data was the input to the model, and the model is giving us text, speech to text. So that is the model, speech to text model. That's what we are going to train upon. Speech to text. That is what this model is converting to. And the first thing we did was we passed a particular speech data to the model. And we had the corresponding correct conversion, the manual conversion. So what is the input we are having? We have two things. One is the speech, 1.wave, 2.wave, 3.wave, and so on. These are audio files, speech files, wave files, or MP3, whatever it is. They are audio files. And we have the corresponding correct translation, or the text, T1, T2, T3. So these are the inputs we are having. Now, what we are going to do, we are going to give this 1, 2, and 3, the files, which are speech to the model. We are going to keep that. And we are going to get some text. So T1.1, T2.2, T3.3. So these are the output files we are getting from the model. These are not exactly same as this. So let me draw it in a different color. So this red one is the output from the model for the corresponding speech audio files, which is given here. So these are the text files the model gave corresponding to this audio files. Now, what we are doing, we are comparing these files. We are comparing these files to understand how accurate the model is. And we are coming to an error rate depending on how much the model got it right or wrong. Let's say it is 20% error rate. 20% is the error. 20% of the pronunciation in this particular audio file, the model got it wrong. So that is the first thing we did. The default model, we fed that model some audio files and we compared what is the output of the model and corresponding correct values or the conversion of the corresponding text. So this is the correct value and this is the output which we got from the model. And when we compared these two, we got 20% error. So 20% of the words in this input or this correct human generated translation is wrong, the model has created. So the model got 20% of the output incorrect. Now, what we did after that, we trained the model. We trained the model with data, words, which are present in this text. And after the training, we generated another version of the model. So let me draw that in a different color. So this blue color is the new model and we have given some data. We have given some text. What is the content of the text? Nothing but the words the model got wrong. If you remember correctly, they are very complicated dinosaur names. And those correct spellings we have fed into the model during the training phase. That's what we have done. And after the training, we have generated a new model with a new training information. The model learned new words which we have given in this particular text file. And those new words, the model is going to take it in, convert the same speech in a different way or more accurate way. So we are going to pass the same speech files or the audio files to the model, and the model is going to give us another version of the text file which is more accurate, which is say C1.1, C2.2, C3.3. So these files are more accurate than this because the model has been trained with some data. We have seen all this in the previous lesson. We have done all this manually. Then again, in the end, we are making sure that we are comparing this output right here and correct output, the human generated output. We are comparing that. And we need to get a smaller error margin, say 5%. 5% is the error rate after the training. That's the intention of the training. So initially, the error rate was 20%, and after the training, the error became 5%, only less amount of error because it is being trained by a domain-specific data. So that's what we have seen in the previous lesson. Now what we are going to do, we are going to automate the whole thing. So the idea here is to repeat the whole process. For example, we did for dinosaurs. Next day, we want to do the same for mountains or place names or people's names. So many different types of data we want to train, which the model doesn't understand. So we need to automate the whole solution. So MLOps is all about that, improving the model, training the model on a daily basis. So let's discuss about MLOps in a nutshell or a subset of MLOps. So you have a model, just like the speech one we had. And the first version is V1 version of the model. And we are giving some input data, and this input will give an output, just like the text in our previous case. And we are going to examine the output. How much is the output is correct? What amount is correct? What amount is wrong? To reduce the amount of incorrect output, what we are going to do? We are going to train the model. So there is a process of verification of the output. So we'll test the output. So there is a testing phase coming up. So this is the testing of the output obtained by the model. And based on the testing, we will determine how good is the model. And we train again. We will keep on training for different inputs. Input 1, input 2, and so on. And we keep on training V1, V2, V3, and so on. And every time we will keep testing the model as well. So there are more testing coming up after each training. So what is the purpose of testing? The main purpose of the testing is nothing but V2 is always better than V1 and V3 is always better than V2. And for that matter, it is better than V1 as well because V2 is better than V1. If V3 is not better than V2 or V1 for that matter, we will not consider V3. So we'll discard V3 after the training. So V3 is not better than V2. What's the point of using V3 then? We can use V2. So always the latest model should be better after the testing. The error rate should be less, or whatever testing criteria we are using: hallucination, reasoning ability, speech to text accuracy, anything, whatever is the testing criteria that has to be met. We need a better value than the previous version for the particular input we are interested in, just like in the case of dinosaurs. And once we get a better model, what we are going to do, we are going to deploy the whole thing. Once V3 is better than V2 or V1 for that matter, we are going to take that whole thing and we will deploy. We'll deploy and replace V2, the URL of V2, with V3. So the final output will be V3. Previous one was V2 because V2 was better than V1. So this is all automated. Automated in the sense that there are scripts, automated scripts, we'll see shortly, running to test all these things. What we are doing is we are giving only the input and the training data. The input, training data, a couple of things we are giving. Rest of the things are all automated, including the deployment. So in a nutshell, we are going to automate pretty much what we have done so far from the Azure Studio, the Speech Studio. Whatever we have done from the Speech Studio, we are going to automate the whole thing. So one of the things I would like to do is to search for MLOps just to see how the real world MLOps is different or more complicated than what we have seen so far or what we have explained, which is a pretty straightforward use case of MLOps. So we have a lot of different articles here, mostly from Google, then Amazon Web Services, AWS, and of course Microsoft. I have found the Amazon article more concise and easy to explain. So feel free to read through it. We are not going into the details of too much into the MLOps part of it, but a couple of things I would like to highlight is that it is not as simple as what we just looked at. It can be more complicated. There could be more moving parts for MLOps. For example, in this case, there's a lot of effort going into the preparation of the data itself. In our case, we just uploaded the data in the code as well. That's what we are going to do. We are now going to automate the entire data processing, which could be a huge part by itself. Cleaning the data, getting properly labeled data using automation. That is this part. Training and tuning, that's what we have seen. Training the model. Deploy and monitor. We have seen that we are testing the model. We are testing the model towards a benchmark or a previous version of the model. Then only if the testing is success, then only we are deploying it. And finally, the end users who is really using the model. And in some cases, the data from end users can be used for the data preparation. A lot of these LLMs use that data these days. What people talking to it. It saves the data and used for further training for a later version of the model. So in this example, we have data preparation where we get the data, then training and tuning, fine tuning or training the model, and deploy and inference. Inference is nothing but using the model, calling the API. So it is a pretty good article. What are the principles of MLOps? Version control, automation. We have seen version control in Git. In the Python training, we'll see the files which we are going to use saved in the Git. But in this case, we have to talk about the version control of the model itself, along with the version of the training data, which is slightly more complicated than simply version controlling the text files, like in the case of simple CICD. So automation is all about coding the whole thing, which we will see in the example. Whatever we have done manually, the training and testing everything, we have to do it with some commands or code or REST APIs so that human intervention is minimal. That's the idea of automation. Repeatability. Continuous X. So the X stands for so many things. It can be integration or improvement. Continuous integration, CI. Sometimes it is referred as continuous improvement as well. Mainly refers to the process of building something to test. That's continuous integration. So we'll see CICD shortly. I want to explain CICD as well. It is exactly same as MLOps, just that it operates on slightly different types of data. So continuous X, continuous delivery, CI/CD, continuous integration, continuous delivery. That's the CI/CD. Continuous training. This is very specific to ML or machine learning, training the AI models. And continuous monitoring is the data we have trained. Is that yielding the correct result? If not, we need to revert back. So different metrics like the error rate we have seen. We'll keep watch of the error rate and fine-tune it later stages in different iterations. So in a proper production scenario, governance matters. We need to have a process around pretty much everything to collaborate between people and things like that to get the correct feedback and based on that, take the necessary action. So benefits of MLOps, all the typical benefits of CI/CD or automation in general. That's the benefit. Productivity, cost. I don't know, cost is not mentioned here. I'm pretty sure cost is one of the things you will save eventually by improving the productivity, reliability, and repeatability. Faster time to market, improved productivity, efficient model deployment. Other than this, I have a couple of points of my own is repeatability, cost effective, etc. And the whole thing become more reliable. If humans does repeatedly, it is very error prone. So ClickOps or clicking on things is very error prone. So the way we have done the training right now, that is called ClickOps or click operation or manual. The next we are going to see is automated using commands. So there are different levels of machine learning operations, level 0, level 1, level 2, and so on. And these are a couple of diagrams according to this particular article. A couple of these things can change based on the scenario. For example, in our case, not all of these boxes are there. We have some boxes, we don't have some boxes. So based on the scenario, based on the model, based on the data, based on the output, we can have different configuration. But the general idea is what is discussed here. So what is the difference between MLOps and DevOps? It's a good question. Sounds like an interview question. What is the difference between MLOps and DevOps? To be honest, not much. Basically automating the whole thing. But MLOps is dealing with a lot of different types of input, while DevOps is mostly code. The input is always code for DevOps. You have a code, you need to build and deploy that code. DevOps is all about that. On the other hand, MLOps is not always about code. You can have a lot of different types of data, images, text, speech, videos. Could be anything, your input. And getting the input is another process by itself. Training data. It's a very valuable information. Clean, labeled data. So MLOps has focus on that. Not sure what is being written here, but in summary, that's what it is. Yeah, I don't think this is very well written from the difference perspective. So the difference between MLOps and DevOps, in my view, at least, is DevOps is all about code. The input is always a Git repository sitting somewhere. That's where you start your DevOps pipeline. MLOps, not much so. You are always starting with some kind of data. In our case, the data is the speech. And obtaining that data, probably you need another level of automation to obtain that data in many other cases. So that is the major difference. The code or the automation code changes according to that. We'll see that shortly in our example. So this is not really our topic. Probably we will get into it more when we discuss the AWS AI services, which is not what this training is all about. Just wanted to give you a bigger picture of MLOps. That's why I gone into this particular page. You can refer to other pages. Google has a similar page. Azure has a similar page, but I found this is more general, except this last part, which is dealing with AWS, which we are not discussing anyway. So I discussed about CICD or DevOps, which is very similar to MLOps. In fact, probably MLOps has the roots of DevOps. So I'd like to talk a little bit about that using Blackboard before we progress into our example. DevOps or CICD, that's what we are going to discuss. So like I mentioned, the origin or the start of the CICD always comes from a Git repository. Let's assume that we have a Python application sitting somewhere. So this is a Python application, and there are a lot of code bases of that application in different repositories. In a modern world scenario, there is something called microservices, which is nothing but big application is divided into small different applications, and they call REST API each other. Now, this is a Git repository. So this is a Git repository with some Python code inside it. Now, normally the next stage of a DevOps pipeline or CI/CD pipeline is taking this code from the Git repository and build it. So there is this thing called building. So building can mean a lot of things, but most of the cases the output of build is a container. So build. And the output of the build stage is a container image. You can read more about container images or Docker container images. These days, Docker is not much used, but we use Docker container just to make things clear and easy to understand. So the output of the build stage is a Docker container image, and we normally upload this Docker image into a Docker repository. So it is a storage, just like the blob storage, if you know what I mean. The blob storage to save file like ACR, Azure Container Registry. Pretty much a lot of products are there which you can use to save container image. This is at the end of the day a file or a group of files. Now what this contains, this container image, this contains the whole code. This code inside this Git repository, probably in the exact same format. For example, in the case of Python, it'll be same format. But in the case of Java or C# or some other programming language which needs build, it'll be the compiled code. Basically the code itself in a slightly different format. Don't want to get into the details. I have so many trainings, other trainings which explain the process. But this container image is just a file which contains this code in the same format or a slightly different format. Now, another important thing which the container image has is the dependency of the code. Remember, we have done so many pip installs so far in this training. We've been installing the dependency. Dependency is nothing but the code developed by someone else for our code to work. That is the dependency. So that is another thing the container image is going to have. So basically, what the container image or the build process is doing is to make this code stand alone with all its dependencies and ready to execute. All the pip install, all those things ready to execute. Make sure that it runs in a very generic environment. That is this Docker image is all about. You can think of it like a zip file which has all the dependencies and the code associated with it, so that the application can simply run in a Linux box. And once that is done, we upload that to a container registry. So this process is called CI. This whole process is called CI. Let me draw a box around it. CI. So this is called CI or continuous integration or continuous improvement. Some places I have seen using improvement, but normally it is called continuous integration. The idea is starting from Git, where a developer is, or a group of developer is checking in some code, and it triggers a build and create a container or a container image. It's not creating a container, it's always container image in the ACR or container registry. So converting a commit, git commit, to a container image is normally called CI or the build. Now, after that, there are a couple more things need to be done. We need to deploy this container image. So we have a container image now. What is next? That's not doing anything. We are not running anything. The application is not useful so far. So what is next? We need to run this particular container. So for that, we have different environments. So sometimes we have dev environment, then we have test environment, then we have SIT environment or system integration, then pre-prod, and finally the prod or production. So what is this environments? Environments are nothing but we have a container image here and we are supposed to run that container, run the application code. So that is where these environments comes into the picture. Normally this is done in the modern days in products called Kubernetes, where you can run the images. You can read more about EKS or AKS or GKE if it is Google. There's all different Kubernetes engines, Kubernetes services, Elastic Kubernetes service, Azure Kubernetes service, Google Kubernetes engine. It's all similar things in different cloud providers. You can have your own hardware Kubernetes cluster, kubeadm clusters. Basically, the idea is nothing but running this image you have uploaded here with a lot of bells and whistles, reliability, security, clustering, failover, high availability, cost optimization, different pillars of well-architected framework. But long story short, you need to run this container image we have generated here using this code right here somewhere. Then only you can execute the code you have written here. This developer has put some code inside. You need to run that code. So for running that code, you need to deploy. So this is called deployment. So you need to deploy this particular image into one of these environments. Normally, a developer deploys his image into dev environment. And once it is deployed to dev environment and he's happy, he promotes the code. It's called promotion into test environment. Normally, automated test is running inside the test environment. If the developer is happy with his code in the dev environment, he runs the test in the test environment. Automated testing towards the code he has committed here. Now, if that is success, he will promote again to system integration. System integration is nothing but he's integrating his code into the rest of the platform. Probably it's a huge application, which has a lot of other dependencies. REST API dependencies, payment gateways, Google Maps, Azure AI services, a lot of different system integration to different companies, for example. That is what happens here in the system integration stage. So he promotes, if the test is success, he promotes the code. Now, if the system integration testing, there will be some tests will be running here, system integration testing, further promote to pre-prod. Pre-prod is very similar to production, probably something called a blue-green deployment. Pre-prod is exactly similar to prod. And some testing, manual user acceptance testing. Pre-prod is sometimes called a UAT as well. Is conducted in pre-prod, and if everything goes fine, normally with a manual verification, in some cases, will promote finally to production. So this is called a CICD pipeline. So this part is the CD part. Let me draw the CD part. So this box right here, which I'm drawing right now, is the CD or continuous delivery or continuous deployment. So just like the name, there are a couple of different names I already spoke about. These boxes can be different as well. For example, in so many cases, dev is merged with test. In some applications, it doesn't make any sense. And some people doesn't have money for pre-prod. So they may have simply prod. So for some small projects, they just have dev and prod. If it is working in dev, they run some unit tests and directly promote to prod. So a lot of different options are there. Depends on your priority, your criticality, your cost, your security, all kind of stuff. And in some cases, it can be very, very elaborate. There are hundreds of things you can do here. Code scanning, container scanning, security scanning of the code, There are a lot of different products you can attach to different stages here to analyze and fix things. Now, there are a couple of different tools we use for CI/CD. The most popular tool and probably the oldest is called Jenkins. You can search more about it, Jenkins. Now, there are cloud versions of Jenkins. For example, Azure DevOps does the same thing as Jenkins, more or less. AWS Code Pipeline, Code Deploy, Code Build, pretty much again same as Jenkins. In our case, the example we are going to see, we are going to use something called GitHub Actions. GitHub Actions. Again, very similar to Jenkins. I'm not going into the details of any of it, but we will see some details on GitHub Actions. The idea is very simple to automate all these different stages to make life easier in terms of executing these different stages. That's the idea of these tools. And most of them have a very nice little UI where you can control the behavior in a very deterministic way and intuitive way to make things easier. Now, what is the reason for why we are discussing this here, CI/CD? Because MLOps is very similar in terms of the process. We have some training data. Like I said, most of the training data may not be in Git because they are not text files, but we are building a model and creating a model. In our case, it's not Docker image. Our output is not Docker image, but it is a model sitting somewhere. And then we are testing the model. We have the test part of it. And then we are going to deploy that model to an environment like production if the test goes good. Here itself, you can see we don't have a couple of stages. We don't have ACR because we don't have a Docker container. That's very common in the case of CI/CD. Based on the scenario, you skip, you add, depends on what you want to do. Basically, the automation of the whole thing, that's what CI/CD is all about. So we have seen some of the concept of CI/CD, continuous integration, continuous delivery, and machine learning operations in general. Training the model, giving the data collection, etc. Now, let's see some practical in the same topic.